how do windmills work, and how strong of an energy can a windmill generate? Windmills. So a windmill. Okay, let's go to Google and see what a windmill looks like. Okay, we'll go to blank Google and say windmill. Windmill. We got an image. Nope. Nope. Google search. Images. A windmill. So this is a windmill. I'm sure we've all seen them. We've had historically we had these smaller windmills. This is something that you would see in Don Quixote, Don Quixote, and Sancho Panza. That story. That's what ancient European windmills would look like. This sort of thing. And then you have modern windmills that you will see all across the hills and everything. If you are in India, there are lots of hills and the Western Ghats and wherever else that you will see mountains and hills that have hundreds of windmills placed atop them on the slopes, wherever it's easy to catch wind. So this is what a windmill looks like. Okay. So it's essentially an object. It's a machine, very simple machine. You have a stand. As you can see, there's a stand on which there are these turbine blades, usually three blades, and the blades are configured in such a manner that they will catch the wind, and the wind will make the entire contraption go round. Okay, so it's gonna move in this circular fashion. So that's what it looks like. Now, how does a windmill work? So once again, let's go to the image. A windmill, let's say diagram, right? Diagram. So, what are the constituent parts of a windmill? Okay, there are various names. So, we have the blades, the turbine blades or rotor blades, let's call them. Okay, and the wind makes these blades turn. Now, there is a shaft which connects the blades, the blade apparatus to a gearbox, and the gearbox will then turn uh, this system, and there is a generator with copper coils or whatever, and essentially what it does is it produces electricity through electromagnetic induction. That's what it does. So you will learn in electromagnetism that moving magnets, when magnets move, they generate an electric current, and when electricity moves, it also generates a magnetic field. Electromagnetism is all about electric and magnetic fields. So through electric induction, they this machine generates electricity, and it depends how much energy, how much electricity, not energy, electricity, a windmill generates depends on the size. It depends on the size of the turbine, on the size of the entire not the turbine, the blades. It also depends on the size of the entire windmill. It also depends on the weather conditions, the wind conditions, and all that, and so on. So generally, when it comes to a windmill, once the speed of the blades of the turbine, it reaches 5 to 10 kilometers per hour, that's generally when it starts generating electricity. And I think if it reaches 20, 25 or beyond, it's going to shut off automatically just for safety. And so a windmill that is used, let's say privately in a home, or in a, yeah, let's say a private windmill, a private wind turbine, will generate electricity in the kilowatt hour range. But commercial and industrial wind turbines, which are like the giant ones that we see from far away from aircraft and all, those will generate electricity in the megawatt hour range. And there is an energy capacity also for each wind turbine, which is a dimensionless number. It's a fraction, zero point 0.1 to 1.0. 1.0 is not attainable, so it's generally 0.25 to zero point 0.5, zero point 0.6, and that tells you how efficient the windmill is. So that's what it is. It's a very complicated engineering subject, but the fundamental basic simple principle is that it generates electricity through a phenomenon called electromagnetic induction. That's what it is. So it's essentially free energy. Wind energy comes from the sun. Okay, you have the planet, half of it is dark, half of it is in sunlight, at any given point in time. So the half of the planet which is experiencing sunlight is going to be warmer, and the half of the planet which is currently dark nighttime is going to be cooler. So you're going to have a warm side and a cool side of the planet. And when you have hot and cold, then there's going to be currents of air, because cooler air is heavier, hotter air is lighter. So cooler air will flow towards the hotter side, and so on. So there are these currents of air that are generated, and that's how wind is generated in the atmosphere of the earth. And there are low pressure areas, high pressure areas, and so much. It's very complicated. Trillions of parameters, I would imagine. That's why you need supercomputers to predict weather patterns. So that's how wind is generated, and the wind is generated because of the heat that's coming from the sun. So it's free energy. So it's good to have to harness that, because that is great. You don't have to burn fossil fuels to generate that energy. Of course, it is not very reliable. Wind can stop and start, and it's not always reliable, but it's good to have this. So that's what windmills are, and that's how it works.